Today, we will learn about the proofs of two frequently used formulas in calculus, the product rule and the quotient rule. Let's start with the product rule. Consider two functions that are in the form of multiplication. These two functions are continuous and differentiable within a given interval. As you may know, we'll use the limit definition. We add and subtract the terms highlighted in red in the numerator. Since we are adding and subtracting the same terms, the equivalence is maintained. We then factor out f, x plus h, and g, x. Using the limit sum property, we take the limit separately for the two fractions. Applying the limit product property allows us to take the limit for each term. Therefore, the product rule is derived as f, x, g prime, x, plus g, x, f prime, x. This formula can be extended to functions with more than two factors, following a similar differentiation pattern. Let's take an example and differentiate x cubed sine x, l, n, x, with respect to x. It becomes 3x squared sine x, l, n, x, plus x cubed cosine x, l, n, x, plus x cubed sine x, 1 over x. Now, moving on to the quotient rule. Similar to before, we use the limit definition. We combine the numerator by finding a common denominator. We simplify the complex fraction. As in the product rule, we add and subtract the terms highlighted in red in the numerator. This maintains equivalence. Factor out g, x, and f, x, and take the limit for each term. Move the terms independent of h to the front of the limit. This results in the well-known quotient rule, which is different from the product rule as it involves a fraction, subtraction in the numerator, and a squared term in the denominator. See you next time.